Hello, my name is Brandon Hughes, and today my awesome group and I will be demonstrating how to use a pH meter properly. First, the pH meter has a rod connected to it. At the end of the rod that you are seeing being pulled out of the container is a bulb. The bulb at the end of this rod is a thing that measures pH. It is very sensitive though, therefore it must be gently washed off every time before and after use with deionized water. The pH rod must be calibrated with a buffer solution to be sure it is accurate before being used to test the pH of a solution. A buffer is composed of a weak acid and its conjugate base and water. The buffer solution in this video is a solution with a pH of 4. After the pH rod is calibrated, it can be used to test the pH of a solution. In this case, we are testing the pH of acetic acid. A strong acid is a strong electrolyte that is completely ionized in water that shifts equilibrium to the right towards the products, and the weak acids are weak electrolytes that only ionize to a certain extent, shifting equilibrium to the left. When strong acids dissociate, they produce a high concentration of hydrogen ions, and when weak acids dissociate, they produce a low concentration of hydrogen ions. The pH of the acetic acid solution happened to hover around the 2.80 range. After adding a few drops of phenolphthalein to the solution and titrating it with close to 40 milliliters of sodium hydroxide, we measured the pH again. This time the pH hovered around the 7.30 range. After using the pH meter, you have to wash the bulb off and place it back into the container. We know that a buffer is composed of a weak acid and its conjugate base and water. The addition of sodium hydroxide to the acetic acid solution formed a buffer. When sodium hydroxide dissociates, it donates the conjugate base of water, which is the hydroxide ion. As a result, both conjugate acid-base pairs, water and the hydroxide ion, and acetic acid and the acetate ion, remain in solution, which would thereby allow the neutralization of any small added amounts of added acid or base. Per the Henderson-Hasselbalch equation, an ideal buffer is one in which the pH is equivalent to its pKa. In order to be equivalent, the concentrations of the acetate ion and acetic acid must be equivalent. As mentioned, when a small quantity of a strong acid or base is added to a buffer solution, the added acid or base is neutralized by the conjugate acid-base pairs. However, when a large quantity of acid or base is added, the ratio of acetate ions to acetic acid becomes too great for the buffer to stabilize, resulting in a change of pH.